Moon, and then Mars? If so, you're in the right place. The journey to answering these questions begins right here on Earth, where our planet's most extreme environments are used as testing grounds for future missions. During today's show, you'll have the chance to ask your own questions and hear directly from our experts about how their expeditions are preparing us to explore the Moon, Mars, and beyond. You can drop your questions into the comments wherever you're watching or use the hashtag AskNASA on social media. Now, studying other worlds may sound like science fiction, but it often begins in some of the most breathtaking places right here at home. Recently, NASA's Goddard Instrument Field Team traveled to Iceland, a landscape shaped by fire and ice. Its rugged terrain makes it an excellent training ground, mirroring many of the conditions scientists will encounter on the Moon, Mars, and other worlds. By investigating these analog environments, our scientists are learning how planets work and paving the way for Artemis missions that will return humans to the lunar surface. Coming up, we'll meet some of the team to take your questions live on air. But first, let's take a look on the ground in Iceland.
So we just hiked up the slopes of the Hekla volcano in southwest Iceland. This particular site is important for lunar research. The regolith on the lunar surface is pretty fluffy, and we think there could be small grains of water ice hosted within that. So today we have a few of our teammates setting up some ground-penetrating radar surveys, and what it does is it makes a 2D slice of the subsurface, and we use that to understand what sort of material we're looking at.
Look at those reflectors.
Oh yeah.
Let's go look at ice grains. We brought in an auger to drill down into the subsurface to confirm our observations.
Auger in hole.
So that we can actually ground truth the observations that we make with the GPR.
Yeah, and you can see the sparkles of the ice.
That's a gift shop.
Yeah.
That's really...
Nothing can a Mars polar scientist more exciting than ice crystals. Ooh, I'm so excited for show and tell.
We have something to show.
So we're gonna drill through the snow and look at the transitions from snow to ice to volcanic sediments. We'll get going. Hopefully we'll see some ice cemented volcanic sediments, and then we'll see how deep we can get.
Yeah.
Yes!
Yes!
And so a lot of the ice as we move through here has different characteristics. Some of them are just filling tiny pores. Some of them are actually cementing it. As they look for ice underneath the surface, what I am trying to do is learn to characterize that ice and do that using visible imagery like cameras and how best to capture them to help learn how we can prepare our astronauts in the future.
I'm just really excited about the prospect of doing actual geology on the surface of the Moon and as we work our way toward Mars.
So it's really a dream come true, and I can't believe I'm actually going to be a part of it. And so I'm so excited.
I'm joined now by Emily Shoemaker-Thaxton, a planetary scientist who you just saw on top of an active volcano in Iceland. Emily, that's amazing. So cool. Thank you so much for being here with us.
Thanks so much for having me.
So again, we just saw you on top of an active volcano doing science. Can you kind of put us in your shoes? How was that?
Yeah, it's really breathtaking when you get to the top of a mountain like that and you're looking down over this unvegetated landscape, and that looks a lot like Mars or what the Moon might look like. Yeah. And you can really just put yourself in the shoes of the astronauts, or boots, I should say, on the surface of those worlds when they go out to explore them in the future. So for me, that was the most exciting part.
Yeah, I mean, it really looked otherworldly, which is amazing. So can you remind us, what was it you were there to do? And what were you trying to learn?
So we went out into the field with three main objectives. One was to think about how much ice there is and what it looks like. And then can we actually measure that with the ground penetrating radar that you saw in the video, so geophysical instrumentation. And then we were interested in how deep it actually is. So is it accessible for future astronauts? And we did that with a variety of tools, including the GPR. We also had, you saw our drill and auger where we were pulling up samples of ice from the subsurface. And then we were imaging all of our samples with a camera and trying to understand how astronauts might actually do this on the moon when we get there.
So you really were putting yourself in like the boots of the explorer. So you mentioned GPR. Can you tell us what is that?
So GPR is ground penetrating radar. It's an electromagnetic geophysical instrument. So what that means is we're actually sending microwaves, like you might have in your home, down into the subsurface, and that bounces off of different materials, and it returns to the radar system at different speeds. And from that, we can actually know what we're looking at in the subsurface.
That is so cool. Now, I have one more question, but I want to remind our viewers at home, start sending in your questions for Emily by dropping them in the comments wherever you're watching, or send them in using #AskNASA. Now, Emily, again, you told us about what you were doing, what you were hoping to find. Can you help explain, how will this help our future astronauts? Are they planning to do this on the lunar surface one day?
Yeah, so the tools that we had out in the field with us, we were actually trying to think about what they would really have on the surface. And several of those they probably or possibly will have. So there's actually been a type of ground penetrating radar selected to ride along on the lunar terrain vehicle, so the cart that the astronauts will be riding around on the surface, that can help them do their surveying. And they also might have access to things like shovels or drills and retrieve the samples, and they'll certainly have cameras. So we were trying to really think about what they're doing on the surface, how they'll do it, and what would be most helpful as we look for this buried water ice.
Amazing. So I do have a question real quick from Emily F. on YouTube, who asks, wow, this is so cool. How often do these teams go into the field, and do they study or learn different things depending on the time of year?
Oh, yeah, certainly. So that's a great question. Our particular team tries to go out maybe once or twice a year. We usually try to go in the summer just because that's safer for us in these really cold environments. Iceland can be really snowy and dangerous in the winter, so we tend to go out when it's a bit warmer. But you definitely learn different things at different times of the year, and the seasons sometimes might correspond to what we think other planets might be like. So the analog could depend on the time of year too.
Amazing. So I have a great follow-up question. It's from Guy the Dude Human on YouTube, who asks, do you guys at NASA always go to Iceland to prepare for space travel, or do you visit other places? And if you do, what are some examples?
Yeah, great question. No, we don't only go to Iceland, though I will say Iceland offers one of the better really accessible analogs for us. But we've gone to other places like the Valley of 10,000 Smokes in Alaska, which is a very remote location on the Katmai Peninsula in Alaska, where we were looking for actually similar questions. Some people were looking at the volcanoes that were there. My team was looking at buried ice, as you can imagine. So we go all over the world. There's really no limit to what a good analog might be on Earth.
Is it just a coincidence that that was also a volcano? Is there a correlation between volcanoes and looking for water ice?
No, that was just a coincidence. Just because of the climate there, it's very similar to Iceland, so it just happened to be a good spot.
Awesome. So we have another question from Ask Plex on X, who asks, are Earth and Mars made? Basically, do they have the same materials? And I know a little bit earlier we were talking about your instruments could also apply to finding water ice on Mars. And so could you talk a little bit about the potential of water ice on Mars, if that's a thing that future explorers could actually look for?
Yeah, certainly. So yeah, there are similar composition rocks to what we might find on the Moon or Mars. And so in some cases, depending on what your science question might be, you might want to look at that. And can you remind me what you wanted me to address too?
Well, yeah, so right now you were looking for water ice, but for the Moon aspect, Is that something that future astronauts could discover on Mars, too?
Oh, yes. Yeah, thank you. Yeah, there's certainly a lot of water ice on Mars, and we've actually been mapping that for decades now using orbital radar instrumentation. So we actually think there's many meters of ice buried at different latitudes on Mars, and certainly you have 2 polar ice caps on Mars, very similar to Earth.
And so when you're looking, even in your experiment for Iceland and the moon, are we looking for like big pockets of water ice, like cubes, little grains of ice? What are you searching for?